Time domain analysis of first order Rl&Rc circuit. So in this only, so the resistor is a common element. Okay, inductor and capacitors is different. The resistor just dissipate the energy in the form of heat. Okay, it is an energy dissipating device, not a energy storage device. Just dissipate the energy in the form of heat. Resistor, but inductor and capacitor is different. Understood? So this V is equal to I into R, the voltage across the resistor, and the current flowing in the resistor is equal to V by R. You know well these relations. Okay, the power consumed by the resistor is called power is equal to I square R, that is called V square by R. Okay, energy is equal to power into time. The energy lost in resistor is equal to energy is equal to power into time, that is called I square into RT. This is called heat dissipated by the resistor. Heat dissipated by the resistor. Okay, dissipate the energy in the form of heat. It is not a storage device. Okay, it is not a storage device, just dissipate the energies in the form of heat. Okay, and then coming to the inductor store the energy in the form of magnetic field. Okay, inductor store the energy in the form of magnetic field, electromagnetic field. This is called electromagnetic field. El is equal to half Li square. No? So this is called electromagnetic field. Understood? This is called electromagnetic field. Energy stored in inductor is called electromagnetic. Okay. So by using this inductor, we have to generate the magnetic field. Okay. So by using inductor, it is possible to generate magnetic inductor. That means it stores the energy in the form of magnetic field. Okay. By using inductor is nothing but just a coil. By using this coil, so we have to generate magnetic poles, north pole and south pole. Okay. By using this coil, it is possible to generate poles. That is, by using coil, it is possible to create magnet. Okay. The energy stored in inductor is called El is equal to half Li square. Okay. Half Li square, that is called electromagnetic field. And here this voltage across the inductor VL is proportional to the di by dt. Is proportional to the change in current. Okay. Change in current. So the voltage across the inductor VL is proportional to the di by dt. That means a change in current. The voltage across the inductor is proportional to the change in current. That means if current flowing through the inductor is constant, for example, if I is equal to constant, okay. So what happened? So what is the voltage across the inductor? VL is equal to 0. If I is constant, means di by dt is constant. This term constant means di by dt is equal to 0. Then VL is equal to 0. So VL is equal to 0 means acting as a short circuit. Understood? So the inductor will be acting as a short circuit if the current flowing through the inductor is constant. Okay. If the inductor is current flowing, the inductor changes, then only the voltage across the inductor is present. Otherwise, this voltage across the inductor is equal to 0. Understand? So energy stored, the inductor store the energy in the form of magnetic field, and so the inductor opposes the sudden changes in current. Okay, opposes the sudden changes in current. Sudden changes in current. Inductor does not allow the sudden changes in current. Okay, inductor does not allow the sudden changes. This inductor. So this is the main property of the inductor. Does not allow the, okay, so does not allow the sudden changes in current. Sudden changes in current. In current. Inductor does not allow sudden changes in current. Okay. So the current is not allowing means the current is not allowing means for this is an inductor. For example, sudden changes in current means for example, this is the step. This is the DC. For example, this is the DC. So time. This is the current I. Okay. So this is the DC na DC current. Direct current DC. Okay. So at t is equal to 0, at t is equal to 0, this much of current is appear across the inductor. Understood? At t is equal to 0. But after t is greater than 0, this is the time period. This is the time for t is greater than 0. Am I right? At t is equal to 0, this much of changes in current. At t is equal to 0, this suddenly increasing current. Current increases suddenly, okay, this much. So increases to like this at t is equal to 0. Within the time, within the microseconds or milliseconds, the current reaches to the maximum value. So at this duration at t is equal to 0, inductor not allow the sudden change in current. Okay, at t is equal to 0, inductor not allow the sudden changes, does not allow the sudden changes in current, sudden changes. Okay, so that's why it acting as a open circuit. Okay, so that's why it acts as a open circuit. Okay, understood? At t is equal to 0 is called at t is equal to 0 it is called transient response. T is equal to 0, time t is equal to 0, this time t is equal to 0, the response is across the inductor is called transient response. Okay, transient response. This response is called transient response. Understood? At t is equal to 0. That means at the time of instant of switching actions, the time at the instant of switching action, 0 time, within the time, milliseconds or microseconds. Okay, that response across the inductor is called transient response. Inductor does not allow the sudden changes in current. Inductor not allow the sudden changes in current. That's why the current does not allow the sudden changes in current means current is equal to 0. Current flowing through the inductor is equal to 0. It's clear? Inductor, this is called inductor. Inductor does not allow the sudden changes in current. That's why open circuit. Open circuit means current is equal to 0. Current flowing through the inductor is equal to 0. That means it acting as an open circuit. Understood? So this is the inductor. So it's like acting as a at t is equal to 0 at the instant of switching action. Okay, at t is equal to 0. Okay, it is not allow the sudden changes in current. Okay, this is called current flowing into the inductor. At t is equal to 0, what happens means it acting as an open circuit. Okay, it acting as an open circuit. So this current IL is equal to 0. Understood? So because of this is the inductor and capacitor having energy storage devices. Energy stored in inductor is called magnetic field, electromagnetic field. So by using inductor, it is possible to generate the magnetic poles. For example, so this is called one pole. Okay. So this is called one pole and this is called another pole. Understood? So by using this inductor, the inductor is nothing but just a coil. The coil is placed here. Okay. The winding is placed on the core of this. So like this. Okay. Similarly here also, if you are placing the winding on this. Okay. So like this. Okay. The flux lines are if you are placing the winding is like this in this core. This is the current direction. Okay. If it is current direction like this, according to the thumb rule. Okay. So it will be acting as a north pole and it will be acting as a south pole. Understood? Similarly here also, it will be acting as a north pole and it will be acting as south pole. Okay, that means energy stored in magnetic field. Energy stored in inductor is called like magnetic field. Understood? So by using this inductor is just nothing but a coil. Okay, inductor is nothing but just a coil. So by using this coil, so it is possible to generate magnetic fields. Okay, so the flux leaving from this in this direction, north to south, the leaving a flux direction in this direction. This is called flux. Flux leaves from this winding or core, so like this, in this direction. This is called flux. Here like this. You can easily understand when I'm explaining this the third unit. Okay, machines, transformer and machines can easily understand. Okay, by using this coil, so we have to generate this electromagnetic field. It's called inductor. Understand? Store the energy in the form of magnetic field. It does not allow the sudden changes in current. That's why it's acting as an open circuit. It acting as sudden changes. It does not allow the sudden changes in current. That's why it acting as an open circuit. It does not allow the sudden changes and it's not allow the current means current open circuit. Current is zero. That's why it is acting as an open circuit. So at the instant of switching action, that is called T is equal to 0. So this time increases to suddenly this maximum current. That's why it's not allow the sudden changes in current. That's the response is called a transient response. Understood? Another response is also there. So that is at T is equal to 0 is over and at T is equal to infinity. At T is equal to infinity, this type of response is called steady state response. Steady state response. Understood? Steady state response under steady state condition. For example, this is the inductor. This is the current flowing through the inductor I. So this is inductor. Under steady state condition. So what is the current entering from this inductor? One terminal is equal to the current here. Entering is equal to the outgoing. Current entering into the inductor is equal to the current leaving from the inductor. Okay. For example, here 2 amps means same also here 2 amps. Okay. Complete current passing through the inductor. So 3 amps is 3 amps. Okay. That means so it's not opposing the current. That's why it is acting as a short circuit. Okay. Acting as a short circuit. Under steady state condition, inductor acting as a short circuit. Understood? This is the main concept. Under transient condition, inductor acting as a open circuit. Okay, under transient condition, inductor acting as a open circuit. Understood? This is the main concept. Here, one of the main concept is called under steady state condition, that is called T is equal to infinity. Okay, the inductor acting as a short circuit. So because of is not allow the I mean there is no opposition current. Okay, whatever the current coming from the input terminals, it's flowing outside from the inductor. Okay, so that's why the inductor will be acting as a short circuit. Okay, that means here current I is constant. Understand? Current I is constant. That is called VL. V is proportional to the di by dt. No? So di by dt is current constant means is equal to VL is equal to 0. No? That means VL is equal to 0. So voltage 0 means short circuit conditions only the voltage 0. Am I right? It acting as a so inductor, so like this. So inductor, no? This is called the current. Okay, this is inductor and this current. and then it will be acting as a short circuit like this. Okay, so under short circuit condition, what is the voltage? Is equal to 0. Resistance 0 now. VL is equal to I into R. V is equal to I into R. So what is the resistance? 0 under short circuit condition. Then voltage VL is equal to 0. For inductor, so for resistor, so resistor units here ohms. Okay, so in resistor you can call as a ohms, your units ohms. Inductance is Henry. So the inductance can be represented in the form of reactance also. Okay, inductive reactance. So it's having some reactance. Inductor is having some reactance. That reactance is called inductive reactance. So it's having some reactance. It opposes the sudden change. Some voltage drop, that is called inductive reactance. Inductive reactance. So inductive reactance when it is subjected to the AC. Okay, under AC conditions only, so we'll get this type of reactance. Okay, when the inductor is subjected to the AC, but is so yeah, time domain analysis first order in Rl&Rc circuit for DC excitation. Okay, for DC excitation only. So that's why, so only this concept you have to take. So only resistor and this concept. If it is AC, if the inductor subjected to the AC, so the reactance concept coming to picture, that is called reactance is equal to XL. Okay, XL is equal to omega L. This concept coming into picture. So when it is inductor is subjected to the AC. Okay, we will discuss in second unit this concept. Okay, so this is the about inductor. So our main concept is inductor during transient condition. Transient condition at t is equal to 0. Transient condition means main concept is transient condition. Transient condition. So that is nothing but t is equal to 0. Okay, at the time of switching action. Okay, inductor does not allow the sudden changes in current. Am I right? So transient condition means this is the condition. This condition at t is equal to 0 condition. Okay, so this much of current. So for this case, inductor does not allow the sudden changes in current. I is equal to 0. It's not allow the sudden changes in current. Okay, current is equal to 0. That's why under transient condition, it is acting as a open circuit. This is the main concept. Okay, second response. Okay, steady state response. Understood? Steady state response. Under steady state condition, that means at t is equal to infinity. Understood? At t is equal to 0 is called transient response. At t is equal to infinity means this is the response. At t is equal to infinity here. So at t is equal to 0, this is the no? So at t is equal to infinity. So this is our response. Okay. Under steady state condition, the current is constant. Understood? Current I is constant. Okay. That means so V is equal to L into dI by dt. So then I is constant means VL is equal to 0. Voltage 0 means short circuit. Okay. Short circuit. So this is the condition. This is the main concept. It acting as open circuit under transient condition. It will be acting as open circuit. Under steady state condition, it will be acting as a short circuit. Understood? This is the main important concept of this inductor. Understood? Capacitor. Okay, energy stored in capacitor is called energy stored in capacitor is called electrostatic field. Okay, electrostatic field. Understand? Energy stored in a capacitor is called electrostatic field. So that is called uh, energy stored in a capacitor EC is equal to half CV square. So half CV square. C is the capacitance. Units are farads. Capacitance units farads. Okay, or millifarads or microfarads. Okay, microfarads or millifarads. Okay, or picofarads. So generally it's farads. Okay, half CV square. So joules. Energy stored in capacitor of CV square. That's called electrostatic field. Understood? Electrostatic field. Energy stored in capacitor is called electrostatic field. That is called of CV square. Okay. So capacitor. So this is called a capacitor. No? So capacitor. Capacitor. So this is called current flowing to the capacitor IC. The voltage across the capacitor is called VC. So the current flowing to the capacitor IC is equal to C into dVc by dt. Okay, this is the current flowing to the capacitor. Understand? And this capacitor does not allow the sudden changes in voltage. Capacitor does not allow the sudden changes in voltage. Sudden changes in voltage. Okay. So capacitor does not allow the sudden changes in voltage. Inductor does not allow the sudden changes in current. That is the property of inductor. And what is the property of capacitor? Does not allow the sudden changes in voltage. Okay. So not allow the sudden changes in voltage. Understand? So not allow the sudden changes in voltage means, okay, so voltage across the capacitor is equal to 0. Sudden changes, that is called at the time of transient response, at t is equal to 0. Okay, during at the initial conditions or at transient condition. For example, this is the voltage. For example, this is the voltage. Okay, so DC voltage. This is called voltage across the capacitor, we see, and this is called time. At t is equal to 0, okay, capacitor does not allow the sudden changes in voltage. Okay, capacitor does not allow the sudden changes in voltage. That's why VC is equal to 0. Okay, so voltage 0 means open circuit or short circuit? Short circuit. Voltage 0 means short circuit. Current 0 means open circuit. Current 0 means open circuit. Voltage 0 means short circuit. That means at the time of transient condition, at the instant of transient condition, under transient condition, t is equal to 0 means transient condition, transient condition at the instant of such action, that is called t is equal to 0, transient condition, capacitor will be acting as a short circuit. Okay, capacitor will be acting as a short circuit. Understood? So this is the property of capacitor. And at t is equal to infinity, what is the voltage? What is the voltage across the capacitor? It's a maximum. At t is equal to infinity, okay, that means like this. At t is equal to infinity means here. Here. So this is called at t is equal to infinity case. So what is the voltage across the capacitor? So this is called, for example, this is called maximum voltage VC. So what is the voltage across the capacitor? VC. Okay. So Vc is a constant. Okay, now constant. Vc is constant. Okay, at the time of t is equal 0 only, this voltage 0. So not allow the sudden changes in voltage. That's why so voltage across the capacitor Vc is equal to 0, and at the time of at a steady state condition, t is equal to infinity means steady state condition. Under steady state condition, under this steady state condition, this means t is equal to infinity. So Vc is constant. Okay, so that means Vc is constant means maximum voltage appear across the capacitor. Capacitor charges to, okay, charges to maximum voltage. Capacitor charges to maximum voltage. Okay, so that means Vc is equal to Vc maximum, that is constant. Then Ic is equal to C into dVc by dt. No? This Vc is constant. Then Ic is equal to 0. Okay, Vc is constant. Constant means so Ic is equal to 0. The current flowing to the capacitor is 0 means acting as an open circuit. This is the main concept. Okay, in the capacitor under steady state condition acting as a open circuit. Understood? But inductor under steady state condition acting as a short circuit. Understood? Under steady state condition, capacitor will be acting as a open circuit. Okay, under steady state condition, inductor acting as a short circuit. Understand? Under transient condition, inductor acting as a open circuit. Under transient condition, capacitor acting as a short circuit. Understood? So this is the concept regarding the inductor and capacitor. Everyone is clear? So about inductor and about capacitor. Store the energy in the form of electrostatic field. So that's why the capacitor can be used as a batteries. So if the number of capacitors connected in series and parallel, it will be acting as a battery. Okay, store the energy stored in capacitor called electrostatic field. So that's called DC. Okay, energy stored in capacitor is called. Okay, so like this, if you are connected two plates of the capacitor, the positive charges are placed on this capacitor like this, and the negative charges are placed on this capacitors like this. Store the energy in the form of electrostatic field, that is called DC. If the more number of capacitors are connected in series and also parallel, it will be acting as a battery. It can consider as a battery. By connecting more number of capacitors in series and parallel, so you can make a battery. Okay, so this is the concept about inductor and capacitor. For example, so based on switching actions, this inductor is open circuited and short circuited. Okay, so first, for example, this is the switch is connected like this. Okay, this switch is connected like this. Okay, in between here at t is equal to 0, let us assume at t is equal to 0. So that means at t is equal to 0, switch is at t is equal to 0, switch is closed. Switch is closed. At t is equal to 0, switch is closed. Understood? So this is the meaning of the switch, and this is the arrow indication current direction. Okay, this arrow indicates current direction. Understood? This arrow indicates current direction, and this arrow indicates switch position. At t is equal to 0, switch is closed. No? This is the meaning. Understood? This is the meaning of the switch. So it is going downward direction means it is closed. At t is equal 0, switch is closed. At t is equal 0, the switch is going downward direction means it is closed. Okay, then current here flowing through the switch. Understood? At t is equal 0, switch is closed means so before switch is open, then only is possible to close. Okay, before means before switching action. At t is equal 0, switch is closer means before t is equal to 0. That means, for example, t is equal to so 2 milliseconds. At 2 milliseconds, the switch is closed. At 2 milliseconds, switch is closed. Okay. At 2 milliseconds, switch closed. So that means what about at 2 is t is equal to 1 millisecond? So before na, switching action, before switching action, that means switch is open, switch open. Then only it is possible that t is equal to 2 milliseconds. Am I right? Switch open. Then only it is possible to close the switch at t is equal to 2 milliseconds. Before 2 milliseconds, the switch is open. That means before t is equal to 0, means that condition is called as t is equal to 0 minus. This instant is called t is equal to 0, and this instant is called t is equal to 0 minus. Understood? This instant can be indicated by t is equal to 0, and this instant is indicated by t is equal to 0 minus means before switching action. This is called before switching action. Understood? Before switching action, me 0 minus. This is 0 minus means before switching action. Before switching action. Okay. T is equal to 0 means at the instant of switching action. It's called instant of switching action. Instant of switching action. T is equal to 0 is called at the instant of switching action. T is equal to 0 minus is called before switching action. So like this. By using the example, you can easily understand. Okay. So this is the meaning of the switch. The current enters like this, and the current enters like this, and it's leave like this. Okay. At t is equal to 0 means the indication downwards is going in this switch is moving on the downward direction means there is maybe a closer contact between these two. So because of switch is closed. Okay. And then so another position of the switch can easily understand another position of the switch. So for example, so this is the position of the switch, upward direction. Okay. So upward direction. This is called same example at t is equal to 0. Okay. This current enters like this. So what is the meaning of this at t is equal to 0? At t is equal to 0, switch is open. Understood? So it's going upward direction. Okay, the switch is moving down upward direction. Okay, so like this, it's moving upward direction. Am I right? That means closer contact to open contact. Understood? Already the switch is closed. At t is equal to 0, the switch is open. Then only it is possible to open the switch. Am I right? If it is closed, then only it's possible to open. Already open switch again open is not it's not a meaning. Already the switch is open. That means again it is open is not that is not a correct meaning. If the switch is closed, then only it is if the switch is closed, okay, then only it's possible to open. Am I right? So that means at t is equal to 0 means for this case, okay. So t is equal to 0 means it acting as an open circuit. Understood. For example, same example, at 2 is equal to 2 milliseconds. Let us assume at 2 is equal to 2 milliseconds. Okay, 2 milliseconds. T is equal to, T is equal to 2 milliseconds means switch is open. Okay, switch open. So, and at T is equal to, so what is the condition before switching action? Okay, so for example, before means 1 milliseconds. Before 2 milliseconds means 1 milliseconds. Before switching action, the switch is in under closed. Understood? Switch is in switch closed condition. Then only it is possible at T is equal to 2 milliseconds, so open. Okay. Try to understand. This is one of the important concept. So, and also it is very difficult to understand the. Okay. If you are not concentrated this concept, it is very difficult to do the problems. Okay. Switching actions, mainly concentrating on switching actions. Understood? So based on switching actions only, you will get the problems in external exam. Okay. So this concept, basics concept is required. Otherwise, it's very difficult to solve the problems. Okay. It's very difficult to solve the problems without knowing this concept. Without knowing this concept, it's very difficult to solve the problems. It's very difficult. So this basics concept is required to solve the problems. Compulsory questions will be there based on this concept in external exam. Okay. At t is equal to 0, at t is equal to 1 milliseconds, the switch is closed. That means same as here also. T is equal to 0. This is case is called at the instant of switching action. So that is called the same as here also. It's called at the instant of t is equal to instant of switching action. So this is called instant of switching action. Understood? So this is a t is equal to 0 minus, no? So minus means before switching action. 2 milliseconds here, up before 2 milliseconds means 1 milliseconds. After 2 milliseconds means 3 milliseconds or 4 milliseconds or 10 minutes after 2 milliseconds means. Understood? That means under steady state condition. So this is the time. Okay. At t is equal to 0, so this is the is called as before switching action. Understood? Before switching action. So this is the these are the two different type of switches. Okay, representation of the switches is like this one. Okay, and then here, so well, time t is equal to 0 is called transient period. Time t is equal to infinity is called steady state period. And then coming to the that concept, the switching action concept. So long time before switching action, long time after switching action. At t is equal to minus infinity is called long time before switching action. At t is equal to plus infinity is called long time after switching action. This is called steady state response after switching action. This is called steady state response before switching action. And this is called transient response. T is equal to 0 at the instant of switching action. Okay, that may be switch is closed or open. This is called at the instant of switching action. That is at the instant of after switching action. T is equal to 0. So after that, there is operations on switches called that may be open or closed. That actions is called switching actions. Okay. So that is called just instant of after switching action. And then at t is equal to 0 minus is called before, just instant of before switching action. That may be that means before the instant of switching action. T is equal to 0 minus 0 before that action is called t is equal to 0 minus. That means switching operations on the circuit before before instant of actions. Okay. So this is about switching action. So you can easily understand this remaining concept. So Okay, this is called the time domain analysis of first order RC circuit. All of you consider this concept.